Okay, good morning. Welcome to
FamilyMath252a.
FamilyMath252a. So yesterday we did a really cool talk about continued fractions in pi, right?
Yeah.
And then I saw this amazing post online yesterday based on a program that a guy named Josh Bowman had written. And I saw it based on someone else's post, and I'm just looking it up right now just to make sure I give credit where credit is due here. A guy named Stuart Price posted this. And so we're going to talk about pi and circles, which doesn't seem that surprising, but I really should have called it powers of pi.
Powers of pi.
Powers of pi and circles. But first we have to talk about complex numbers, which are sometimes called what?
Imaginary numbers.
Imaginary numbers. So we like to look at imaginary numbers in a plane where the real numbers go this way
Yep.
and the imaginary numbers go this way. And there's a very special circle that people call the unit circle, which goes a distance of 1 in each direction.
Sort of.
Sort of. So this is 1. A distance of 1 in the imaginary direction gets you up to what?
I.
I. Now let your brother answer this one. A distance of 1 going backwards this way in the real direction gets you where?
-1.
-1. And a distance going down in the imaginary direction, a distance of 1 gets you where?
-I.
-I. Good job. -I. And there are some really interesting patterns that get formed when you're looking at
The unit circle.
the unit circle and roots of 1. Okay?
Yeah.
So, for example, what numbers are equal to the square root of 1?
Well, 1 and
1
and -1.
and minus 1. 1 and minus 1. That's because 1 times 1 equals 1,
Yeah,
and minus 1 times minus 1 equals
minus is 1.
minus 1. But here's maybe a more difficult question, and I'll let you guys both think about this for a second. How about the fourth roots of 1? What numbers can you raise to the 4th power and get 1? Can you tell me an example of a number that you can raise to the 4th power and get 1?
Well, maybe 1.
1 is an
One
example. 1 to the 4th equals 1. I'll mark that. Can you think of another example? Can you think of one?
Well, -1 to the 4th power.
Minus 1 to the 4th power is 1. Very good. Because minus 1 times minus 1
Is
1. And then I have 2 more minus 1s I have to
So that would be
use.
1 times 1.
1 times 1, okay. So I found 2 numbers so that when I take them to the 4th power, I get 1. Are there any others?
Well, what about I?
What is I to the 4th?
I squared is -1.
I squared is minus 1.
So I to the 4th would be I squared times I squared, or -1 times -1. Which is just 1.
Which is 1. Ooh, we found another one. Cool. There's 3.
I need more. Well, maybe minus I? What about
Well, what do you think? What do you think about minus I?
Well, minus I is negative square root. It's negative square root of -1.
Right. So what is minus I times minus I?
It would be, it would be 1.
Well, what do you get when you do minus I times minus I?
Well, you get I squared.
How come you get I squared?
Because minus I times minus I.
Minus times the 2 negatives
Like the positive.
cancel each other out. So this is the same as I squared, which is
Which is -1.
minus 1. So what's minus I to the 4th then?
Then minus I times minus I, -1 times -1 is 1.
So minus I to the 4th is?
So minus I, it's 1.
It's 1. Hey, so look at that. Interestingly enough, there were 2 numbers whose square root was 1. Or sorry, there were 2 numbers such that when you squared them you got 1. There are 4 numbers so that when you take them to the 4th power you get 1. And they form a nice pattern on the unit circle.
Cool.
Just like these formed a nice pattern on the unit circle too.
Yeah.
And it turns out that when you take the nth power,
Just
the
the
nth root of 1, you get a regular n-gon. Isn't that interesting? So the
Cool.
fifth roots of 1 form a regular pentagon. One of the vertices is 1.
Yep.
If I take the 10th root of 1, I get a regular decagon.
Decagon.
One of the vertices is 1.
When you take the 1th root of 1, you get a point.
That's right. That's right. But when so there's a very interesting pattern here, and it gets into trigonometry, but there's also a neat relation to pi. So these guys, in their project they saw yesterday, they asked, what are the pith roots of 1?
You'd form a pygon.
A pygon. Now the difference between an integer and pi is that an integer is a rational number.
And pi isn't.
Pi is irrational. So it's an interesting question.
What does a pygon look like?
Yeah, what does a pygon
You'd
look
have
like?
to have 3.14159 faces.
Well, we're going to explore that in just a second. We have to revisit one thing from yesterday first, okay?
Yeah.
Alright.